Oh my goodness, instead of changing the scene, I almost just clicked the end stream button, which would have been no good. Hope you all are having a good night. It's Thursday, which means that it was chemo day for Mel, which is always a little rough. Today was our first afternoon chemo, so a little tired. For her and for me. And also I went running this morning, but I had no energy, so luckily we already got our file all set up and everything, so at least that'll be nice. And let me come over to the Twitch thing real quick and make it so that people aren't going to have commercials in the middle of the thing. So hopefully that shouldn't be too much of a problem. Yeah, I'm not really seeing any real people as far as I can tell. Yeah, that seems fake. That seems fake. All right, so there's no real people in my chat, but that's okay. They'll show up eventually. Yeah, I hope y'all are having a good night. I'm wondering what tonight's problem is going to be. If we go to my personal stats, we can see this last time, 897. It's our best result since day two, so pretty excited about that. But the problem still only took 11 minutes and 20 minutes, so we're looking for something that's going to be a little bit more interesting than that. Let's go ahead and take this off. Oh, and let's turn on the light so you guys can see my face. Oh, there we go. Light is on, face is visible. Well, just this side of the face, but you know, that is a-okay. All right, and what is going on here? Okay. Sorry, people are talking about sports stuff in the group me. I need to go look. In fact, I'll look over here. We have, how long until we get started? 3 minutes. Okay, plenty of time. Let's go to ESPN. Georgia Bulldogs is fine. We're going to go over, check out the NFL, look at the scores and see what happened. Oh, Army Navy is playing. The Rams beat the Raiders. That's pretty shocking. Box score. Let's go to the play-by-play. Yeah. And it looks like, yeah, touchdown. And then Derek Carr immediately gets an interception. Jeez. But yeah, Baker scores with 10 seconds left. Oh, and that's why there was a deep pass that gets intercepted. Wow, and it looks like he... a 8-yard pass to the 23, spikes it, and then a 23-yard pass to Van Jefferson. Wow. Fascinating. Good job, Baker. I am not really rooting for the Rams, but, you know... I'm a University of Georgia fan, and we beat Baker Mayfield in his last ever college game. Go Dogs. And so anytime I see him doing well, I think, well, that just makes us look better, you know? So no real complaints there. There we go. Let's skip a little further down the list. Yeah. Let's go one up. Nice. We've been listening to these same set of attribution not required, calm jazz and blues songs. I need to find if there's a different genre that's a little bit better for this, but I'll figure that out for another day. Today's not a day brimming with energy. Another interesting thing that I found out about the site is if you click 2022 here, it slightly changes some of the @ symbols and hash symbols, which I don't think really changes the picture that much. Okay, so let's look. If we were trying to get to like just the blank 2022, oh, it's random, so we can't even see. But I was looking to see if we can like find a, it's just the @ symbols and the hashes. So I want to see like, is it random? Like if we get var y equals 2022 and then we get that again, is it still going to be hashed for a @ symbols and then a hash again? Or is it something different? So we're just waiting for var y equals 2022. As we have 43 seconds left. Year, Y, thing, year. Come on, we're looking for var. Show me var. Var. And now it's not giving me var. I'm waiting forever for it. Sub. Okay, I give up. I can't get it to show me the same thing again, so we're just going to chill out and wait the 15 seconds for this problem to start. We're wearing a button down, which, but you know, nothing to do about it now. 3, 2, 1. Day 9. Day 9, rope bridge. This rope bridge creaks as you walk along it. You aren't sure how old it is, or whether it can even support your weight. It seems to support the elves just fine, though. The bridge spans a gorge, which was carved out by the massive river far below you. You step carefully. As you do, the ropes stretch and twist. You decide to distract yourself by modeling rope physics. Maybe you can even figure out where not to step. Consider the rope with a knot at each end. These knots are marked by the head and tail of the rope. If a head moves far enough away from the tail is pulled towards the head. Due to nebulous reasoning involving plank lengths, you should be able to model the positions of the knots on a two-dimensional grid. Then, by following a hypothetical series of motions, your puzzle input, for the head, you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching. Diagonally adjacent, and even overlapping both count as touching. If the head is ever 2 steps directly up, down, left, or right from the tail must also move 1 step in that direction so it remains close enough. The head moves 1 to the right, so the tail moves 1 to the right, the head moves 1 down, so the tail moves 1 down. Otherwise, if the head and tail aren't touching, and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Up and right, tail also moves... Oh, the tail always moves 1 step diagonally. So this one, the head went up 1, but the tail went 1 step diagonally to get the correct distance. This one, the head went 1 to the right, and the tail went diagonally. So it goes up and right. You just need to work out where the tail goes as the head follows a series of motions. Assume the head and tail both start at the same position, overlapping. For example, right up, 4 up, left up, down 1, right 4, down 1, left 5, right 2. This series of motions moves the head right 4 steps, then up 4 steps, then left 3 steps, then down 1 step, and so on. After each step, you'll need to update the position of the tail if the step means the head is no longer directly adjacent to the tail. Visually, these motions occur as follows. S marks the starting position as a reference point. So head, then head tail, then head tail, then head tail, etc. Then it's going to go up, and then it's going to drag the tail with it, and then it's going to go left, and it's going to drag the tail with it, and then it's going to go down, and then it's going to go right. And see here, we were there, here, and then here, and then here, and the tail didn't move. And then tail still doesn't move, and now the tail finally snaps too. So it's kind of like we're doing a little lagging indicator. After the simulation, you can count up all the positions the tail visited at least once. In this diagram, S again marks the tail position, which the tail also visited. Number marks the other positions the tail visited. So there are 13 positions the tail have visited at least once. Simulate your complete hypothetical series of motions. How many positions does the tail of your rope visit at least once? Let's get our puzzle input, see how big this is. Very, very long. Gotcha. Cool. So let's go ahead and put this in level 9 data, and string line equals scanner dot xline. So we want some kind of like point variable, and then we want to get like the yeah. So we can create a little class to help us with this. Private static class point point int x int y, and then we want void move int xdiff int ydiff. And let's see, let's give it private int x y, this dot x equals x, this dot y equals y, x plus equals x diff, y plus equals y diff. And then we want, oh dang, we got the capitalization wrong there. There we go. And then we also want, Boolean, like not even Boolean. Void move towards if necessary, and this is a tail function which takes in a point head. And so we'll come back to this to do. So what do we want to do for a line? String command equals, oh, we're lagging. I don't know why we're lagging, but we're lagging. Equals line dot split. Oh, come on. Why are we so laggy? What's going on? So we want a point head equals new point 0, 0. Point tail equals new point 0, 0. Gotcha. And then we want like for int I equals 0, I is less than what is it? Command 1 integer dot parse int command 1 plus I, because all those numbers are positive, right? So then we want like switch command 1 case u. We can't use a switch statement on strings because it's not going to do the right equality, is it? It might do the right equality. I don't want to find out if that's a bug. If command 0 dot equals up. Nope, we got to do it this way. That should be fine. Else, and then we want the same if whatever. Oh, nope. In fact, we probably wanted to do it like this. So that let's do up, let's do down, let's do left, and then this case can be right. We don't actually have to check for that. So if it's up, we basically want to move like head dot move, and we want, in this case, the x diff is 0 and the y diff is 1. In this one, the x diff is 0 and the y diff is -1. If it's left, then it's head dot move, y diff is 0 and x diff is -1, and otherwise it's the same thing but +1 when we move to the right. And then we want tail dot move towards, if necessary, head. And then we want, basically what we now want is we want a set, and we want a set of pairs of integers. How can I represent that in an easy fashion? Oh, we could probably override equals here and just create a new point. Point copy, return new point this dot x, this dot y. This is a little cumbersome, but that's fine. And then we want at override Boolean equals. Is that right? Let's look up Java override equals. Java override object equals. Overriding equals method in Java. Thank you very much. Blah blah blah. It's blah 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 blah, etc. etc. So we need to like add a thing. That's fine. At override public Boolean equals. This has got to be public. And that is object O. Does that look right? That does look right. So if O equals this, return true. If not, O instance of point, return false. And then we want point P equals We need to cast it now. Point O. Return integer dot compare. Let's see, p dot x. We probably want to do this dot x first. This dot x. P dot x. Actually, we can just do it this way. This dot x equals p dot x, and this dot y equals p dot y. There we go. That should work fine. I think the set only needs equals in order to work, so now we can have a set point tail locations equals new hash set. Is that what we want? So I've got equals, that's fine. Object hash set Java hash set add object. Yeah, I want to see what other things implement the set interface. Is there like a better... I just want to store pairs of points, which seems like it shouldn't be that hard. We also could do something like a lot dumber, but I want this to work. Let's see. Java set of points. There just is a class point. Extends point2d. Java AWT, no thank you. Blah, blah, blah. This can be done in the following way. There's some points. Navigable set? That's also not what I want. Let's see. Blah, 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 blah. Java, make object work with hash set. Doesn't seem to realize that two objects are the same. You need to override object.hashcode. It'll return the same hash code. I see. Huh. So what's a good way? What's a good hash code for us to implement? Actually, let's just go ahead and implement the dumb version. If it turns out to be bad, then override public int hash code. Return this dot x times, I don't know, 1,000,000 plus this dot y. Does that seem right? Then as long as y doesn't get to be of size 1,000,000, then we should be okay. Cool. So let's leave that for now. This is not the best solution, but it's a fine solution. Tail locations dot add tail dot copy. Because we want to provide a new instance so that it's fine. Number of tail locations plus tail locations dot size. Wonderful. That'll count the unique stuff for us. So now we just need to do this move towards if necessary. So let's start with like the simple cases. So if math.abs this.x minus head.x greater than 1, or math.abs this.y minus head.y greater than 1. And we need to do stuff. Otherwise, we don't do anything, right? Like if everything's within 1 distance away, we're okay. So then there's no way that it can be both. So we can actually split this into like an if and an else, right? Else if. So if the x is 2 away, we know we need to move at least. So we know we need to move at least 1. Let's go back and look at the thing. So let's consider. So if the x is 2 away, let's go back to what it shows us in the little examples. So if the x goes over, in this case, like the y went up. So the y was 2 away, and then if the x was different at all, then the x also moved to be the same. So we want if math.abs this.y minus head.y. Actually, if x is greater than 1, then we need to move it. So if this.x greater than head.x, then we need this.x minus minus, else we need this.x plus plus, and then if this.y is less than head.y, then we need this.x plus plus, else if this.y is actually, we don't even need to do this part. The y's always need to end up the same. If one thing is at least 2 apart, then the y is always going to be equal to the other one. So this.y equals head.y. So that part's fine. And this one we want to be off by 1, not off by 2. And so now we can do the same thing for if the y is off by 2. We can basically just copy this and flip all the x's and y's. So y, y, y. Oh, nope, please stop. Y. That should be x, not c. And I think that should be fine. So if we're 2 away in the x, which is what we have to be, right? Like in this example, then we want to move the tail to be 1 closer to where the head is, and they'll only ever be 2 apart. If the y coordinate is 2 apart, then we want to move the y one. And then always in these diagonal cases, you'll notice that they never end up in the diagonal case, because the only way to end up there is they're already diagonal, and then when you move, it drags the tail back like into the plane with it. They end up vertical or horizontal. So we can just take whichever one's not 2 apart and do this. And otherwise, if they're not, if the absolute distance in the x or in the y direction is not greater than 1, then it doesn't move. So I think we're fine. I spent all that time saying that. I should have already run this program. Let's take the simple example and see whether or not we get the right answer, which I always paste in the real stuff. Okay, show me what's going on. 13 seems beautiful. That is the correct answer there. Now if we take this and we run the same thing, I'm gonna wait for it. 63.32. Show me the money. That's right, continue to part 2. The rope snaps. Suddenly the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping towards you as you fall through the air. The ropes are moving too quickly to grab, and you only have a few seconds to choose how to arch your body to avoid being hit. Fortunately, simulation can be extended to support longer ropes. Rather than 2 knots, you must now simulate a rope consisting of 10 knots. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules as before. Using the same series of motions as the above example, with the knots marked H to 9, the motions now occurs as follows. Blah, 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 blah. It's going to do all the stuff. And so what do we want to know? Now you need to keep track of the positions of the new tail 9 visits. In this example, the tail never moves, and so it only visits 1 position. However, be careful, more types of motion are possible than before, so you might want to visually compare your simulated rope to the one above. Here's a larger example. So then a bunch of weird stuff happens, which is fine. We basically update all of the... We just update them one by one, right? There's no, whipping that can happen. Is that right? Yeah, and as long as we update them in coordination, I think we'll be okay. Okay, let's give it a shot and we'll find out if we're wrong. So we basically can copy this same exact thing, everything within the try, except now instead of head and tail, we have so for we now instead want a like point array. Rope points equals, come on, new point array size 10. For int I equals 0, I is less than 10, plus I, rope points I equals new point 0, 0. There needs to be a space there. So we've got that, and so now there's no head or tail or whatever. Now instead it is points 0 dot move, or sorry, rope points. It's a good thing I named this thing so well, because that's the head. This, and so then we want for I equals 1, I is less than 10, plus I. Now we want to run this in here, and we want to go points I dot move towards if necessary, points I minus 1 is rope points. Why didn't I just name it points? And then we want tail locations dot add rope points 9 dot copy. Okay, so now if we take this and we run part 2 here, and then let's run it and see what happens. It's taken a while, but that makes sense. We're doing 10 times as many simulations. You can do it. Let's make sure that we didn't do anything crazy here. Is it running? Still is running. Okay, I'm not sure anything's happening. We're gonna add a little if debug system not out. You headed to bed, sweetheart? Okay. Doing all right. Yeah. I 0. We don't want this to be I. We want this to be line parse count. Thanks. If line parse count %10 equals 0, computed so far, plus line parse count. Just so that we're only getting whatever. Private, static, final, boolean, debug equals true. Cool. And so yeah, this should be fine. Let's stop and rerun. Stop and rerun. Process finished? Oh. Plus line parse count. Okay. 1120. Is that how many lines there are? Like, should we be done? Why did we stop at 1120? What's going on? Okay, so we're stuck at like, in fact, let's just make this 1 and see if we can get it to stop and rerun and see what's going on. Exactly which thing happens here. 1123. So if this is 1123, I want to know what's wrong. What is line 1123? Control G, is it? 1123. Just down 11. That shouldn't be particularly bad. What's going on at that point? Okay, so if this, and let's put the debug statement there, and now let's debug it, and we'll stop and rerun. Then obviously we should get to the point that we're going to do this. Fine, step over. Cool, so we're at 1123 now. Right 12. Okay, so we're off by a couple, but sure. Right 12. Are we fucking up because we're not, No, it's inside the loop. We're fine. Two, 3, 4, 5, 6, 8, 9. Cool. And what size is tail locations? 35? 0, 0. Yeah, 12 minus 13, 4 minus 9. Okay, so that's believable, I guess. So let's add a breakpoint right there. Oh, we can't. Let's add a breakpoint right there. So. Let's just add a little breakpoint right there. So what is I right now? I is 10? Why is this taking so long? What is going on? Oh, do we have an I inside of an I deal? Is that what's happening? Fine. Yeah, we modified the thing. There. That should fix it. Now run, please. Stop and rerun. Int j equals 0. Thank you very much. Gosh. What are we doing here, folks? Number of tail locations 2540. That's nice. Okay, let's return to day 9 and let's go back down to part 2. Part 2, yeah, there's all this big stuff. Let's see if we're getting the right answers or if there's something like wrong with like the math state going on. So here's a larger example. Let's see what answer we get for this. And let's turn debug to false so we could quit getting all of this print spam. 36. And what's the answer supposed to be? There's just 36 locations. Okay. Yeah. And then let's take like the old input where the answer should be 1, which is this. And now if we run 1. Yeah. So let's copy, let's paste, let's run. 2540? Was that not what we got the first time? Okay. So let's see if there's some way that we can just print out all of the points. Let's add a debug statement that every time we get to every 10th line, and then we want system, yeah, 4 into I equals 0, I is less than 10, plus, sorry, not I plus I, dot out dot println point plus I plus it's going to be this. So the first point goes here plus rope points I x plus this, and then this part becomes plus rope points I dot y plus blah 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 blah. So let's see how that goes. Okay, well we set debug to false, so that's fair. Debug to true. And we want we don't even want to. We want like every single one, and we're actually just gonna let's remove all of these things, and then we can just debug that one line. And we can just pause it after every input and see where stuff has gone. Console. And let's go ahead and we can if debug system.out.println line. Great. Command plus line. There we go. Cool. Let's start by stop and rerun. Let's get. Whoa. Okay. Console. Command is up 1. This one has moved up 1. That seems fine. Play again. So this time the command was down 1. So stuff is moved there. And then after all we do this, actually the also thing we want to do is we want to system.out.println tail locations so far plus tail locations dot size. Okay, so let's go ahead and do that. Stop and rerun. Actually, I don't even need to debug this. Just run the whole thing and we can just look at the output and see what happens. So does this make sense? What's the command? Up 2? So let's compare. This one goes up 2, so this one goes so these things are like off by 1, so this one goes up, this one's gonna get dragged to it. And then let me think. Do I have a bug in my code, like if stuff moves like kind of diagonally? Like if my input is like up 1, right 1, up 1, right 1, up 1, right run, like is that plan nice? Or is stuff snapping together too much? Let's see if the tail location jumps by more than we expect. 0, 0. The tails are always in the same spot. Man, it's a good thing I can't spell. Tail locations, not localtions. So when's the first time tail locations is greater than 1? Where's the tail? 0, 0, 0, 0. I don't understand why I'm getting the right answer. Did I like do the logic wrong? Move towards if necessary, and it moves towards the previous one, where 0 is the head. We're always moving rope point 0, and then we're always reconciling immediately, and then we see if the tail's somewhere else, and then we like go back and do it again. Where are all these unversioned files? Yeah, you can add them all, I don't care. Here, let's try some simple ones just to get us started. So what if the command is just like up 14? You expect the location to start where it is, and then when the thing starts going along, like let's see what the output of this is. Tail location so far. So this one ends up 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. That seems right. And 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5 is in fact 6 locations, so that seems fine. And so I assume if we go, like, let's check if we got down 14, the same thing happens. So we're cool. And let's see, what about left 14? Like there's nothing should be surprising about this logic. What about if we go right 14? Okay, cool. And so now what if we go up 1, right 1, and we do that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Then what? Tail location so far is 6, which is kind of surprising. So let's consider what happens near the beginning. So we go to the up one, then we go to the right one, so we're still close enough that nothing else needs to move. And then we go up one, and so that drags this one up, right? Does that make sense? We go up one, we go right one, we go up one, and so this one gets pulled right below it, so, which is what's happening, right? And then right one, and things should be fine, and up one, and this one should get pulled right below it, and then this one should get pulled. Oh, the optimization that we did probably does it wrong, right? So now this is all fine, and so now when we go up one, this one's getting pulled like immediately 0.2 is getting pulled super far when this should only be at 1, 1. Okay, so we just have to go fix our logic here. So this dot y shouldn't equal head dot y. We then want if this dot y less than head dot y. Things can end up like pretty far apart pretty quickly, right? I want to like draw this on my whiteboard. 1 second. Let me see if I can get the camera so you guys will be able to see that. Okay, yes, in theory I can, and if I put it here, okay, we're figuring that out on the fly. Okay, cool. So we have here, and then we move there, and then we move here. So we haven't done it yet. And when we move there, then the second one needs to be here, right? Because it gets pulled like diagonal and over. Then we go there, so things are fine. And so now there's one here, connected to the rest of them here. So then we go up one. Now we have ones here. This one needs to get pulled here, and then this one needs to get pulled here. So this one shouldn't be up. So it just needs to go like up one and or over one. Like it just moves a diagonal one. It doesn't get pulled all the way over. This dot y plus. Else if this dot y is greater than head dot y, this dot y minus minus. Great, and so now if we have this, we want this, and then we just want to replace everything with x here. Then we're going to see if we get a different answer. Okay, and if they're already the same, then fine, but we don't want to move them by more than 1. So now if we run this again, the first time 0.2 moves, it shouldn't move to 1, 2. It should move to 1, 1. That's what we expect. There we go. So now if we run that on the full data set, that should fix our problem. Man, what a dumb bug. That's what we get for trying to optimize. 2511. There we go. Return to the advent calendar, and it didn't show us the cool like, oh, you're in the top 1,000 thing. So yeah, and we actually did markedly worse between parts 1 and part 2. Okay. Let's take a moment and clean up our code, and the way that always... Actually, let's look at the leaderboards. We've done that first every time. So we look here. Yeah, nobody else even tried tonight. We check out the other one. Nobody else has tried for several days. Kind of a bummer, but we're on this journey on our own. We know that to be the case. So if we go back... Man, what a disappointing bug. Also, this thing's gonna be such a pain to put in the problem statement. It's a good thing I don't have anything going on. Okay. Let's go to this, let's full screen it, and let's start fixing. So, I don't know, you belong over here, and we'll just do this a little bit. Let's start at the top, make it drop. Oh, we can't go that far, I can't see all the words. Okay, where not to step, hold. Consider a rope, mark the head and the tail of the rope. Plank lengths, series of motions. The head and the tail must always be touching bold. And then this is all in here. Okay, if the head is circular, blah, 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 blah. None of that stuff matters. We're doing a better job. Otherwise, if the tail blood, there's nothing in here, so just another one of these. Man, I'm going to be glad to have this in the future. It'll be so nice to look back. For example, look at this. Wonderful. Right 4 steps, then up 4 steps, then left 3 steps, then down 1 step. And then we get, there's also S. Marks the start as a visual reference point. Fair enough. Initial state, a long graph until we get to the word after, which is fair enough. Similarly, rope all the positions. The tail visited at least once. Thank you very much. Needs to be a new line here to keep things thing. There are 13 positions, and it wants me to bold all of this. Bold, and actually the question mark goes inside, and my answer was this. Lovely. Part 2. A rope snaps. There's nothing here until we get to H to 9, which we can... Oh, nope, the comma goes outside. Motion now occurs as follows. All of this. There we go. You keep track of the... Oh yeah, look at all of this. 9 visits. If the tail never moves, it only visits 1 position. Man, I'm so annoyed by that bug. We could have had such a really good score. Be careful. Here's a larger example. Clearly, we weren't the only one with that problem. I'm actually very curious how many people even bothered to solve yesterday's. Like, with how many people are we actually competing? We only know how many people we beat, but I'd like to see the total. Blah, blah, blah. Simulate the complete series of things. How many positions? Answer was 2511. Wonderful. Both parts of this puzzle are complete. They provide 2 gold stars. So return your advent calendar and try another puzzle, etc., etc. Okay, cool. Let's go comment the code and then we can explain what we were doing. Starting at the top. Simulate each step of the command given separately. Move the head. Move and track the tail. And then, like, the solution is just the number of places the tail was. Seems pretty easy. This one, okay, and let's actually delete some of this debugging stuff because I just don't care that much about it. So all this can go away. Wonderful. So then it is the same. Simulate each step of the command separately. Move the head. Move each middle and tail piece, reconciling 1 by 1, and track the tail. Okay, that's kind of it. Helper class to represent a point. Equals probably doesn't need to be there. We can add a comment to hash code used to make this class play nice with the hash set. And we can also comment here, 1 million is greater than the highest y value expected in this problem, not suitable for general purpose use. Okay, and then the only thing move towards if necessary. This is the meat of the problem. If neither x nor y are at least 2 apart, you don't move the point. Otherwise, increment the direction that triggered the flag, and then also move the opposite coordinate if they are different by 1. Cool. Don't try to optimize by setting the opposite coordinate to the heads value of that coordinate. That optimization only works for the 2-point case. Okay, cool. So let's explain what happened. So what we want to do is we want to represent a rope just by its head and tail. And so we read in a command, which is something like up 5, you know, or whatever. And so what we do is for each of the 5, for example, that it gives us, we one by one go, okay, we go to up, let's move the head, which we do by like having it move by a single, you know, value in the y direction. And then what we do is we take the tail and we run that move towards if necessary command. So we basically say like, okay, are these points far enough apart? If so, oh geez, and my camera's in the wrong spot. If so, please, as I mentioned up here, basically the way to tell whether or not things are too far apart is, and this is shown visually in the problem, if the x coordinates are, oh no, undo. If the x coordinates are more than 1 away, then what you have to do is you have to like move towards that x coordinate. And then if the y coordinates are different at all, so like for example, if you have points which are like diagonally and then you move here, this tail gets dragged to both up 1, but also like in the x direction 1 towards where the rope is. So that what that actually means though is that like as you start moving, like you'll end up dragging the rope sort of like diagonally, and you won't just like set it to the value, but that's fine. Anyways, so we basically simulate each of those steps 1 by 1, and then every time we do that, we add something to a hash set where we take a copy of the point so that it's not constantly trying to insert the same point, and then we insert that point into the hash set, and we just have to do some object magic there. And basically we compute a hash code ourselves because otherwise it's just going to use the object hash code, which is always going to be different. And so that's just x times 1,000,000 plus y. And because neither x nor y get up to the size 1,000,000, this is a fine solution. Like we don't overflow or anything as far as I can tell. The answers we got were right. So for the input that we've given, this is fine. We just do a little bit of parsing to figure out which direction we're going. For part 2, all we have to do is the same thing, but with an array of points. And the problem that then like what you do is you like move the head, and then what you do is you like move each subsequent one towards the previous one if necessary, and then you figure out where the true tail is, which is the like index 9, which is the 10th point in the rope, and you add that and then count it up. And so we had a little bug there, which you can see how we debugged earlier. Anyways, I think that's all I've got for you guys tonight. Not the hardest problem in the world, but you know we did okay, not great, but all right. Again, our stats for today's problem were personal stats, yeah, 1500th and 2000th, so nothing to like hang our hat on entirely, but well, I mean, not the worst in the world. About 4,000 people have solved the problem already, so even in the little time that we spent cleaning up, you know, as many people as solved the problem overall, you know, have shown back up. So no huge complaints there, and it looks like probably in the neighborhood of 70 or 60,000 people are playing the game, though most of them will be playing that in the morning. Of course, every week you should expect So this is people that only have 1 star, and this is people that have both stars. So actually 7,000 people have already tried the problem. Okay, so our 1,500th out of 7,000 people is not so bad for the people trying right now. Not terrible. Okay, cool. Anyways, I think that's all I've got for you guys tonight. I'll see you tomorrow for more of the same. Have a good one.